Okay, so in this video, we're going to talk about how we find and graph the natural base, or e to the x. E, we say, is a number that is like pi. It's an irrational number. We call it Euler's number. This is a number that's used in physics equations for light waves, sound waves, and quantum waves. You can see here e to the first is approximately 2.718281 and so on. So it's an irrational number. So as we look at the graphing, again, this e to the x is still a exponential function. And so as we graph this, we look at our points here. If I put in 0 for x, e to the 0 power, anything to the 0 power is 1. So 0, 1, that's going to be our y-intercept. If I put in 1, e to the first power is going to be our approximately 2.71. So if I plot that, it'll be approximately right here on my graph. And then if I just plug in a negative 1, a negative 1 is going to give me approximately 0.368. So when I graph that, negative 1, 0.368, that's going to be right down here. Again, we do have an asymptote on this. The asymptote is y equals 0. Okay, so here's my asymptote. And then if I just kind of sketch in my graph, it'll look something like this. And it's going to continue to approach the x-axis there. And it's going to continue to go vertically there for that one. If we utilize our rules, again, y equals 0 was the asymptote, so I'm just filling that in there on the note sheet. If we utilize our rules that we've talked about with our parent functions, if I do this one, f of x equals e to the x plus 1 minus 2, you think about what these numbers are going to indicate. The minus 2 is telling us here that the curve is going to move down 2. So if you think about where my origin is, if I move down 2, and I know that this plus 1 is going to move it to the left 1. So down 2 and left 1, that's almost like my new origin, if you think about it in those terms. And then from there, you're basically going to, plot your points here. If I put in negative 1, or let's just put in 0 first. If I put in 0, I'm going to get 0.718. So 0, 0.718, which is going to be right up here. And if I put in negative 1, negative 1 is going to also give me negative 1. So negative 1 right here, which again is my down 2 and left 1. So that's my point on what would have been my y-axis. And if I plug in 1, I'm going to be at 5.39. So 1. So go up 2, 3, 4, 5, 6, right about here. And then I can just kind of sketch in my graph. My new asymptote here is going to be y equals negative 2. And then here's my curve that approaches negative 2 and continually goes up. So again, the graph has just been shifted. The plus 1 moves it left 1 from my original graph up here at the top, and the minus 2 has moved it down. So hopefully that gives you a pretty good understanding of how we would graph the exponential function when it's the Euler's number or the natural base.